All right, hi guys. So welcome back. We're going to get started on lesson 2.4. In lesson 2.4, we're going to be writing equations of our parabolas given different pieces of information. Okay, so just to start with some vocabulary, average rate of change, you should be familiar with that from Algebra 1. The average rate of change in y over change in x. System of three linear equations. We worked with this in chapter 1. So if you have three equations with three variables, so ax plus by plus cz equals d, where x, y, and z are variables, and a, b, and c are not all zero. Some can be zero, but they all can't be zero. And here's an example. All right, so writing quadratic equations. So we've worked in both of these forms before, vertex form, right? We worked a lot in that form so far this chapter. And then also intercept form, we studied that earlier in the chapter. So the first example we're going to look at together, it says write an equation of the parabola in vertex form. So when you read the directions, it tells you what form you want to be in. So we're going to start by writing that form down. Okay, vertex form. Vertex form is y is equal to a times the quantity x minus h squared plus k. Remember, if your parabola is opening up or down, then this is the form. If it's opening right or left, you switch the x and the y, and you switch the h and the k, okay? A can be replaced with 1 over 4p if you're given information about the focus and the directrix, but if you're not, we use A. A tells you vertical stretch shrink, opens up or down. H and K are your vertex. X and Y can be any point on the parabola. Also keep in mind A is negative if it opens down or to the left. It's positive if it opens up or to the right. All right, so I just gave a lot of information. Let's write what information is given. You're given the vertex, which is 0, 3. So that's your H and your K. And then you're given a point. The point you're given is 2, 1, right? Oh gosh, here we go. 2, 1. That point is given there. All right, this is H and K, and your point is 2, 1. So that can be an X and a Y. Any point that's given can be an X and Y. So this is going to allow you to plug in H, K, X, Y into the equation to solve for A. Because just like when we're in slope-intercept form, you need the M and the B to write the equation. If you're trying to write an equation of a parabola in vertex form, you need A, H, and K. So now we can solve for A, okay? All right, so I'm going to replace the y with a 1. The a is what I'm trying to solve for. X is a 2. H is a 0 squared. And then k is a 3. Combine like terms in the parentheses first. Simplify in parentheses first. 2 squared. So it's important here to use PEMDAS, okay? You're going to do your exponent next. So it's a times 4 plus 3. Now, this is the one mistake I see students make all the time. You're not adding the 4 and the 3 together. What I suggest doing here, 4 times a, you should rewrite that as 4a. If you don't, I promise you, a lot of you are going to add the 4 and the 3 together and make a mistake. 4 times a is 4a. Write it that way because that's the way your brain is used to seeing it. All right, continuing to solve for a. Now I use inverse operations. So I'm going to subtract 3 from both sides. 1 minus 3 is going to leave me with negative 2 equals 4a. Divide both sides by 4, and you're going to have a is equal to net. Nope, it's still going crazy. Are we done? Are we done? Nope, we're not done. All right, so we have A is equal to negative 1/2. I'm sure you guys already figured that out before I got there. I don't know what to do, guys. I turned it off. I took the battery out. I tried everything I could before starting this lesson to make sure the pen wouldn't go crazy. I don't know what to do. All right, so A equals negative 1/2. Okay, after you find the A value and you were given the H and the K value, now you can write your final answer. Now you can write your equation. Okay, so your final answer is Y is equal to A, which is negative 1/2. Y is equal to negative 1/2 X minus H, which is 0, squared plus 3. Now, you can leave it like that, or you don't have to write the plus 0 or the minus 0. The other way of writing it without including that plus 0 would just be Y is equal to negative 1/2 X squared plus 3. Okay, since the H value is just a 0, you don't need to include it. If you do, that's fine. Okay, so that's the first problem. All right, let's move on to the next one. Oops. All right, the next one is really the same. We just don't have a diagram to look at. Okay, you're given a point and you're given the vertex. So you're going to want to identify the point as your X and your Y and the vertex as your H and your K. Write down your equation. Y equals A times the quantity X minus H squared plus K, and substitute the values in. So you have 0 equals A. X value is negative 3. H is a negative 1. Careful with all your signs here. And then plus, or sorry, I should do a minus 8 for that. K is a negative 8. Minus 8. Clean up inside the parentheses first. So you have a negative 3 plus a 1 to give you a negative 2 squared minus 8. Square, take care of exponents next. So you have 2 squared, which is a 4 minus 8. Remember, it's not 4 minus 8. Don't make that mistake. Rewrite it as 4A minus 8. Now you're going to add the 8 to the other side, right? Inverse operations. Now move the 8 to the other side by addition. So you have 8 is equal to 4A. And then you divide both sides by 4. Hopefully your handwriting looks better than mine. You get 2 is equal to A. Okay. Once you know your A value and your H and your K value, you're ready to write your answer. So it's Y is equal to 2 parentheses X minus H. So minus a 1 is plus 1 squared minus 8. And that would be your answer. Okay. The next problem. So you're given the vertex and 2 points, and you're asked to write an equation in intercept form. So make sure you read the directions so you know what form you're supposed to be working in. Okay, so intercept form, Y equals A times the quantity X minus P times the quantity X minus Q. X minus Q minus. Close your parenthesis. Come on. Trying to stay calm, guys. It's hard. I want to scream right now, but I'm not going to. Y equals A, X minus P, X minus Q. Okay. Now over here, notice that your vertex is given as negative 3.5 and negative 1/4. That's your H and your K, right? And then you're given the x-intercepts, which are P and Q. P, -4, Q, -3, or vice versa. It doesn't matter. One is -3, the other is -4. All right, now you might be thinking to yourself, okay, but there is no H and K. You're correct, there is no H and K. Well, instead of H and K, can't they also be X and Y? Oh, I'm gonna quit. I'm gonna quit. I'm gonna quit. I'm gonna quit. All right, so what I was saying is your H and K can also be an X and a Y. They don't have to be H and K. That's just a special letters we give it since it is the vertex, but it also can just be a point. All right, so you're gonna replace Y with -1/4. You guys are welcome to work ahead of me while I'm waiting for my things to stop being crazy. So -1/4 is Y. A, we don't know. X is -3.5. P, I forget which one I said was P and Q, but like I said, it doesn't matter. -4, I'll use for P. X again is still -3.5, so you're using that same X value twice, and then minus a -3, okay? All right, so cleaning up inside the parentheses, you're gonna have -1/2 equals A, and then inside the parentheses, remember it's +4, so -3.5 plus 4 is gonna leave you with a +1/2, and then -3.5 plus 3 is gonna leave you with a -1/2. Multiply, so now I have -1/4 is equal to A times -1/4. Divide both sides by -1/4, and you're going to be left with A is equal to -1. Or sorry, A is equal to +1. A is equal to +1. Sorry, I'm just waiting for my thing to stop being crazy. All right, so A is equal to +1. Okay. Once you know that A is equal to +1, you can write your equation. Okay. So once you know that A is equal to +1, let me erase all this. Then you just substitute in A, P, and Q. So the equation becomes Y is equal to 1 X minus -4 X minus -3, but clean it up. Y is equal to 1 X plus 4 X plus 3. And you can write it like that, or you don't have to include the 1. You could also write it as Y is equal to X plus 4 X plus 3. You don't have to have that 1 there. Okay, so I'll say or between these two. One of these two would be the answer. Okay. All right, let's see the next one. Ooh. The next one is, again, very similar to what we just did. We just don't have a graph to look at. So you're given the x-intercepts are 7 and 10. That's going to be your P and your Q, and it passes through a point. So that's your X and your Y. Again, even if it says it passes through the vertex, instead of H and K, think of it as X and Y. So again, it's Y is equal to A times the quantity X minus P, X minus Q. So I have 27 is equal to A, -2 minus 7, -2 minus 10. Clean inside parentheses first. So 27 is equal to A plus a -7, right? Same change. So it's -9 And then here, same change as well, negative 12. All right. Then you're going to multiply the negative 9 and negative 12 together. So 27 is equal to A, and it's a negative times a negative, so positive 108. Divide both sides by positive 108. And simplify your fraction. So you have A is equal to 1/4. Once you know your A value and you know your P and your Q, you're done. So then you can write your equation. Y is equal to 1/4 parentheses X minus 7, X minus 10. Okay, so in vertex form, you need to know A, H, and K. In intercept form, you need to know A, P, and Q. Just waiting for it to stop being crazy. All right, let's delete. Okay, guys. The next set of problems are calculator-based problems, although we are going to talk about constant first difference and second difference, which I talked about in class one day as well. Okay, so for these problems, if you're, oh, let me go here. If you're, there we go. Your data is going to be linear, so it's linear data. If you have a constant first difference. And then your data is going to be quadratic. If you have a constant second difference. Okay, so what that means is you look at your x's and hopefully they're increasing by the same amount each time. So +1, +1, +1, right? They're increasing by 1 each time, just adding 1. So then you go to your y's and you find the difference between each of the y's. So you have a difference, oh, they changed the problem. Okay, sorry guys. It's different than my notes, which is fine. Okay, so you're going to find your difference 424 minus 416 and get a difference of 8. So you're doing -8. And then you have 416 minus 376. Oops, 416 minus 376, and that's a difference of 40. So you're -40. Let me clean this up because it's kind of messy. All right, so we said that's a difference of -8. Then we have a difference of -40. All right, 376 minus 304 gives you a difference of 72. -72. Then 304 minus 200, you're decreasing by 104. -104 for that one. And then 200 minus 64 is 136. So from that to that is 136. So it's obviously not a constant first difference. So it's not linear. Then we're going to find the differences between those numbers. Okay, so from -8 minus 40, okay, oh, sorry, you are, is that a -40? It is. All right, so -8 minus 40. So it's -48. Then -40 minus 72. It's -112. All right, and I can actually stop there because our constant second difference is not the same. We know it's not quadratic. So you're just going to say this is neither. This is neither linear or quadratic. All right. The next one All right, so for the next one, we can see in the x's, it's plus 3, 3 to 6 is plus 3, 6 to 9 is plus 3, 9 to 12. We're increasing by 3 each time, which is good, okay? So then we're going to see what the differences are of the y's. From 36 to 30, we're decreasing by 6. From 30 to 24, we're decreasing by 6. From 24 to 18, decreasing by 6. 18 to 12, decreasing by 6, and decreasing by 6. So this data is linear. Okay. So then it says if the data is linear, use a calculator to come up with the line of best fit. Okay. So I'm going to go to my calculator. Oh, I have to use my mouse. Sorry. My calculator. And I'm going to go to stat. I'm going to edit my list. If you have data in there like I do, go up and clear it and come back down. Go over, go up to L1, clear, and come back down. You're going to enter the X's in the first list. So I have 0. Then I have 3, 6, 9, 12, and 15. Then I go to my L2, that's for my Y values. Over. And I have 36, 30, 24, 18, 12, and 6. All right, and then what you do is you hit stat, go over to calculate. We said it's linear, so we're going to go down to number 4, linear regression. It looks like slope-intercept form, y equals mx plus b. Go down to calculate. And you're given the a and the b. So this equation is y equals negative 2x plus 36. Oh, I didn't want to clear that, but that's okay. So I have y is equal to negative 2x plus 36. Okay. And for the last set of data, go down a little bit. So the last set of data as well, you're going to find the differences in the y's, and you can see it increases by 10, then it increases, so increases by 10, then it increases by 30, plus 30, then it increases by plus 90, then it's plus 270, then it's plus 810. Then you find the differences of those. Oh my goodness. We're increasing by 20, and then we're increasing by 60. I can stop there. The first difference was not constant, so it's not linear. The second difference is not constant, so it's not quadratic, so this is also neither. All right. Let's go to the last problem. Okay, so for the last problem, the table shows the university budget in millions of dollars over a 10-year period where X is equal to 0 represents the first year in the 10-year period. Okay, so this is the first year in the 10-year period. All right, it says use a graphing calculator to create a scatter plot which represents the data. A line or parabola explain. Well, actually, let's use the first and second difference rule first to figure out if we think it's going to be quadratic or linear. Or no, you know what? Let's just plug it into a calculator, save some time. So let me grab my calculator. I closed it accidentally. Ooh, all right. So plugging that data in, right, so I'm going to go to Stat, and I'm going to edit, and I'm going to clear my list. So my X's are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 8, 8, and 9. And then for my Y's, I have 65, 32, oops, that didn't work, 32, why is that not right? 32, there we go, 22, 40, 65, 92, 114, 128, 140, and 150. So we're asked to determine if a line or parabola quadratic equation fits the data best. So I'm going to make sure my stat plot is on. So second stat plot, it is on, so that's good. So then I should just hit the word graph. Now I might need to zoom stat, right? I don't know where I'm zoomed in right now. So just hit zoom and then number 9, and there is my graph. Okay. So what looks like it fits the data better, a line or a parabola? Well, because I have some data over here, it does kind of take the shape of a parabola, all right? It doesn't show a constant rate of change like a line would, okay? So I would say a parabola fits the data best, okay? So that would be the answer for A. I'm not going to go back and write it. You guys can write it yourselves. Then it says use the regression feature on your calculator to find the model that fits the data the best. So you guys have done this before in the last chapter. You hit stat, you go over to calculate, and you go down to, oh, well, actually we did linear regression, but we're just choosing number 5, quadratic regression, because we said a parabola, quadratic equation. So you hit enter, and you go down to calculate, and you hit enter again. It gives it to you in standard form, ax squared plus bx plus c, and they give you the values of a, b, and c. Okay, so I'll round to, we'll just round to 2 or 3 decimal places for each number. Okay, and I'll go back and write this down on paper with you guys. So this lesson here. So for B, I would say that my equation that fits the data would be y is equal to 1.49x squared plus 0.51x plus 39.98. Okay, if I pull up my calculator again. And show that data again. Okay. All right, so that would be the line of best fit. And then the last question says, use the model in part B to predict when the budget of the university is $500 million. Okay, so we can use a graphing calculator. We can also, at this point, we're just going to use a graphing calculator because we are not going to do a lot of factoring right this second. So what I'm going to do is delete that. I'm going to go to y equals. I'm going to type in the equation that we just wrote on our paper. So we said that that was 1.49, and then I got to get my variable in there, and then I have to square it. So caret, and then the 2. Come out of that, so use your arrows so that you're no longer in the exponent. And then I said plus 0.51, another variable, and then plus 39.90. All right, and then you can graph. Uh-oh, what happened to my line? Why did everything go away? Let me try to enter that again. Mine didn't work. 1.49 x squared and then 0.51 x, and then 39.98, and then hit graph. All right, so it's okay. It's not like the best data, right? But it's okay. And then it says use the graphing calculator. When is the budget? So when is Y 5 million? But since the budget is in millions of dollars, we're looking for when Y is 500. So I've never done it on the graphing calculator on the computer, but let me see what happens if I hit trace. Let's see. Jump over here. Okay, so now on the parabola, I just use my arrow on the parabola. I'm looking for when is Y 500. So if I trace up, and you can see the Y's and the X's are changing, right? I'm just going to scroll up till when I get to about 500. So here you can see Y is almost 500 when X is 8.4. Y is just over 500 when we're at 8.5. All right, so we'd approximate when X is about 8.5, Y is 500. All right, and that would be the answer for number or letter C. Okay. All right, guys, let me just end this. Okay, so that is the last of lesson 2.4. So I'll see you back here for the next lesson. Bye.